Okay guys, this is part 2 of the current extra credit assignment I gave you a day or two ago. The title matches exactly the title on the worksheet, so it should be pretty easy to find the worksheet I'm talking about, if that's a problem. But anyways, let's get right to it. If I'm given this scrambled function here, guys, eventually you'll get good enough where you'll recognize that that's going to be a circle. But the only way to graph it is we need to organize it and get it in standard form. So that's going to be my first step. I'm going to take that x squared, right? Let me make sure I have enough room here. So I'm going to take that x squared, put it together with the 2x. I'm organizing, right? I'm then going to take the y squared, put it together, and make sure I'm not missing the signs there. That is a minus 8y. I'm also going to minus 13 both sides to get this 13 out of the way, right? So that's your first step. Organize the x's, organize the y's, get the number out of your way, right? So now what? We're ready now to complete the square. With this 2 right here, guys, I know based on the pattern, if I divide by 2 or cut it in half, that of course is positive 1. And when I square it, I get that perfect square number I need, which of course is plus 1. I'm also going to add plus 1 to the other side. Now let's do the y's next. See this negative 8 right here, guys? Negative 8 divided by 2 is negative 4. When I square that, I get its perfect square number, which is positive 16. So I'm going to add 16 to both sides so I don't change the value of the equation, right? So now what? Well, if you look at the x's right here with that plus 1, it is a perfect square. It's x plus 1 squared. And when you look at the y's, that's a perfect square. Y minus 4 squared. Remember, guys, it had a negative 8 in the middle, and we squared a negative 4, right? To get 16, keep track of your signs. That, of course, equals, and if we do all of this correctly, we'll end up with 4. Hopefully you recognize the standard form for a circle. What makes this 0, of course, is negative 1. What makes that 0 for the y's is positive 4. This is the center of my circle. So I'm just going to come over to my graph and go negative 1, 4. Bam, right there. I know that's the center of my circle. Now don't forget, guys, the 4 over here is r squared. So don't forget to take the square root of it. So r is 2. So my radius is 2. So from the center, guys, I'm just going to count 2 to the right there, 2 up, 2 spaces to the left, 2 spaces down. I have 4 points on my circle, basically, and I'm just going to connect them with a nice arc. Again, don't stress out if it's not perfect. It's not like I gave you a compass to draw perfect circles with, right? And as long as you have the center and you show your work and you know the radius is 2, you're going to get full credit. But guys, pause the video if you need to. Okay, so we just did a circle. Now, what about number 6? Notice how we have different numbers right here, guys. If the numbers are different, guys, then that generally means you have an ellipse. Okay, let's get down to it and look at the graph when we're done. What's my first step again? I'm going to organize, right? I'm going to put my x squared with my 16x together, here and here, right? And now I'm going to put my 25y squared right there together with the 150y. They're all positive, so that's easy to keep track of signs. And of course, I'm going to minus 141 from both sides to get that number out of the way. So now what? Well, what's different is if you look at the x terms there, guys, it's hard to find a perfect square when there's a coefficient in front of x squared. So before we complete the square, we're going to do a GCF of 4. And that means we have x squared plus 4x. 4 times 4 is 16 after all, right? All right. And leave a space there for that perfect square number we're going to throw in there soon, guys. For the y's over here, we're going to do a GCF of 25 so that we have y squared in front, see? Plus, now 25 divides 150 6 times. All right. Again, leave a space there. And this, of course, all equals negative 141. Sorry, I ran out of room there, guys, but I'm sure you can adapt. So now what? Well, let's now complete the square right here. That 4 divided by 2 is 2. Square it is positive 4. So we're going to add 4 to both sides. Oh, I messed up. I stand corrected. Guys, is this really a 4? Yeah, it is a 4, but do you agree it's 4 times 4? Don't lose track of your GCF like I almost did. Whew, glad I caught myself there. So 4 times 4 is actually a 16 that we added to both sides. Even though it's a 4 there, it's really 16, right? Because 4 times 4 is 16. All right, I won't make the same mistake on the next one, I promise. So everyone agree the 6 right here, if you divide by 2 is 3. 3 squared is 9, so I'm adding 9 in the parentheses, but I'm really adding 25 times 9. And 25 times 9 is 225, correct? Let's see, 8 quarters is 200, right, or $2? Yeah, so 9 times 25 is 225. Okay, so let's see what we got here. We, of course, have the 4. But everything here is now a perfect square. X plus 2 squared. We have the 25 right there. But everything else over here with the y's is now y plus 3 squared equals, now guys, I got to add all of that up together. And when I add that up together, guys, I get exactly 100, right? That's awful convenient for now, but you're just learning these ellipses, guys, so get used to nice, convenient numbers like 100. But anyways, we're almost there. If you remember what I taught you in class, guys, we need to now divide everything by 100 because we need it to equal 1. The standard form for ellipse is always equal to 1 on the right side. So let's see what we got now. 4 over 100, you see, reduces to 1 over 25. So we have x plus 2 squared over 25. Plus, here, 25 over 100 reduces to 1/4. So we have y plus 3 squared over 4 equal to 1. Now what? Well, what makes the x part 0 is negative 2. Look on the left side of my screen, guys. What makes the y 0 is negative 3. Whatever zeroes it out, guys, just like with circles, is the center of your graph. So this is my center. Now, so let's go ahead and plot that. Negative 2, negative 3 is right there. Okay, now what? Well, look at the 25 underneath my x plus 2 squared. Remember, that also is a squared number, guys. The square root of 25 is 5. This tells me the length of x in each direction. So go to the center and go left and right, because x goes left and right. 1, 2, 3, 4, 5 spaces. Bam. There's our first key point. Let's go 5 left. 1, 2, 3, 4, 5. Bam. There's the left part or left edge of my ellipse, okay? Let's do the same thing with y. That 4 right there, guys, don't forget to take the square root of it. Because, again, both of these numbers are squared. So you need a square root to get the actual value. So square root of 4 is 2. This 2 tells me the size of the y-axis, basically, guys, in each direction. So I'm just going to go 1, 2 up and 1, 2 down. If I connect those, I get my ellipse. Okay, guys? And if you have any questions, please ask me in class. But right now, pause the video if you need to. Okay, guys, hopefully you pause the video because I'm about ready to change the screen here. So as I was saying, guys, if you have any questions, please ask me in class about these. You definitely need to know what we call conic sections. That's what they're actually called. And that ends my video, so I'll see you in class. If you have any questions, please ask. Okay? See you then.